Hello everyone, welcome to Programming Knowledge. So I again welcome you all to yet another tutorial at Programming Knowledge. So in the today's tutorial we are going to cover with agency matrix. So you can move to our GitHub link, that is github.com/pro software development, and you can find a repository here named competitive coding Python. You can click on this repository and you can find all the codes which are being implemented in Python prior to this tutorial. So you can run this code, you can run all these codes on your local machine. So let's get started with today's tutorial. Today's tutorial is all about generate all paths in a matrix. So we generate all paths from top left to right bottom. So I'll give you a test case just to explore. Like here you can see I have a matrix 1 2 3 4 5 6 7 8 9. Top left is the source and right bottom is your destination. So 1 here is the source, 9 is the destination, and you can move either right, down and diagonal. You need to generate all paths. So let's code this algorithm. Then we would see our test case. We would run our test case and explore with the results. So what results we get? So let's start with the tutorial. uh, uh, we do this function with DFS or recursive need DFS or recursively, and we look for the like we what we can do. We look for the first we look for the safe index. First, keep we need to check if the present index is valid, and also check what I mean by the index, your current position, that is the cell, or we can say index is matrix of ij. Here you can also refer to this to the current position. Okay, so current index, I'll write current index is matrix of ij. First check if the present index is valid. Okay, so if the present current index is valid, and check if the current index can be explored. Okay, so check if the present index is valid and check if the current index can be explored. So if it can be explored, so move either right, down or diagonal, else we backtrack. So we do this DFS or recursively. Current index is matrix ij. First check if the present index is valid. Check if the current index can be explored. So if the current index can be explored, we either move right, down or diagonal, else we backtrack. So let's define our matrix. We can either take input. So this is the matrix. So for I in range, we can define an integer n is equal to int input. So this would define the n cross n matrix. So for I in range n, we have a row is equal to map. Before map we get a list, integer input dot split. Then we uh, append this row in the matrix, mat dot append row, and then we have a path. Okay, so what we do, we call a function define find paths which has a matrix m, which has a path comma I comma j. Then we call this function find paths mat comma path comma I comma j would be 0 comma 0, because I have told you that the position would be the top left. So this index is 0 comma 0. So let's move back to our code. So now what we do, we also define a function is safe. We can either check this condition, or we can define a function. We can define this function diff define is valid. So what you need to do, you need to pass I comma j, and we need to define I comma j comma r comma c. Okay, so then you can say if we need to define a condition if 0 greater than equal to I comma is equal to r minus 1, and uh, okay, we can do, let it be, we this is not necessary to implement, so we can do this without also. I'll give you that would be more intuitive in nature. So we can define, will implicitly define the condition in the algorithm as well. So so what we need to do for define r comma c is equal to len m comma m of 0. So this, from this we get number of rows and column. So r comma c is equal to len m, len m comma len of m of 0. So from here we get number of rows and column. Then if we reach our destination, if I is equal to r minus 1 and j is equal to c minus 1, if we reach our destination, so if destination is reached, then we simply print. So we don't return here something, because we simply print. So we print path plus, since m of ij is an integer, we convert this to list and concatenate, and we print path. Okay, then we return nothing because we are printing here, so we don't need to return anything. Print path plus m of ij. So uh, like if the destination is not reached, so we explore. So explore means we move down, move right, move diagonal. So here we move down, right, and diagonal. So path dot append m of ij. So we append. So here you can see the difference. This is just a print. We print path plus m of ij, but now we actually append it here. If the destination is reached, we simply print path plus m of ij. If it isn't reached, we need to explore more, then we really append that integer into that path. So just make a difference of this. We here we just print it, but now we really append it. So when we append it, so we look for the cases. So here are the three cases. If 0, so this is the first case for I down function, but I plus 1 is equal to r minus 1, and j should be, for the, we do the same for the j. 0 less than is equal to j is less than is equal to c minus 1. Then find paths m comma I plus 1. We would call this for I plus 1, I plus 1 comma j. So this is the condition for move down. Similarly, we define the condition for move right. So this is the condition for move right. But for move right, what we need to do, we would do j plus 1 and call this function for I comma j plus 1. And for diagonal, we do the same. We call this for I plus 1 and j plus 1. So if, and then in the end, what we do, if none is explorable, if none of the above is explorable or invalid index, so anything doesn't work here, then we backtrack. Then path dot pop. So pop, it pops the that element which we had really appended it. So now let's run this code. So for this test case, I need to put 3 also. 3 is the n. So then 1 2 3 4 5 6 7 8 9. Okay, let me go with the code. Yes, now here you can see I have all the paths. So let's quickly explore all the paths. This is 1, 4, 7, 8, 9. 1, 4, 7, 8, 9. That is down, 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 right, right. 1, 4, 5, 8, 9. Perfect. 1, 4, 5, 6, 9. Perfect. 1, 4, 5. Then we move diagonal 9. So one of the path is also 1, 5, 9. We move diagonally. Then 1, 5, 6, 9. 1, 5, 8, 9. Perfect. 1, 2, 6, 9. 1. Okay, even this is also added 1. Then move right 2. Then move diagonal 6. Then move down 9. So all the paths are absolutely correct. So here you can move this is the way you can explore all the paths. So this is the condition. You can also define one function is valid, and you can check all those condition for move right, down, and diagonal in that function by passing the parameters. So this would save you from writing such lengthy if conditions. So thank you guys, thank you so much. I'll catch you up in the next tutorial.